You might think it's just internal tooling, but we have a lot of internal tooling, just so you know, which is why Effect is actually being used a lot. So instead of running a Python eval suite, on the market, there's a bunch. We write our own, but it's using Effect. So we actually have an eval suite and also a bulk test suite. That's all using Effect with, like Effect retry and so on and so forth. It's a very sophisticated system. I'm just saying is that if we use it, you might think internal tooling is like some toy, but no, we actually using it almost on a daily basis. It's actually a production load. Testing out all the endpoint, right? Which is like a crucial part of our operation. Well, almost every response transformation is using the pipe now. And then also I'm introducing, more and more generator. So that down the line, we finally will be making it easier for us transitioning over to Effect as needed.
Welcome to Cause and Effect, a podcast about the TypeScript library and ecosystem called Effect, helping engineers to build production-ready software. I'm your host, Johannes Schickling, and I've been building with Effect for over 4 years. With this podcast, I want to help others understand the powers and benefits of using Effect. In this episode, I'm talking to Vichy, co-founder of OpenRouter, the unified interface for LLMs. In this conversation, we dive deep into their Cloudflare Workers architecture, their routing layers, and how they're replacing their own result type implementation with Effect for better retries, observability, and long-running agentic workflows. Let's get into it. Hey, welcome everyone. It's so nice to have you here. Luz, you're from OpenRouter. Would you mind introducing yourself? And we also have the Effect co-creator, Michael, here.
Awesome. How y'all? I'm Lewis. I'm a co-founder of OpenRouter's. Me and my co-founder, we met through GitHub, essentially. He was building out the V0 of OpenRouter's using a framework I was building for my previous startup. And that's how we met. And then we just love collaborating with each other. And then, around May is when OpenRouter first launched, May 2023. So kind of early 2023. Essentially, the idea of OpenRouter's is at the bare bone. It is essentially a switchboard for AI models. That's it. We reduce the switching costs between like Anthropic and OpenAI and Gemini and, models from Cohere and Meta to essentially zero, right? And we also centralizing all the payment for you, right? So you, instead of like 60 different providers, you pay just us. And then you get some credit, and then you can call any AI model you want. And essentially, that is the basic product of OpenRouter's. But OpenRouter is actually much more than that, right? You have seen Elon tweet about us on X. The secondary product of OpenRouter is the data that we are allowing everyone else to access. The data about which model is being spent on the most, or which model is getting the most utility. And we measure them based on token. A token is about roughly 4 characters. So last week we did about like 5 trillion token a week. Exactly a year ago though, we were doing about 150 billion token a week. So that's roughly about more than 20x growth, right? And we track this number by the way, this feature was released like literally the first month of the product, I think. We were, basically my co-founder and I we were thinking about, okay, we have this data. Should we just let everyone see it, Because at the time, right, there was so many benchmarks. There was so many Llama, Meta Llama benchmark, Llama 1, right? That claiming some of these Llama 5.2 will be better than GPT 3.5. And we were like, is that actually the case? Or, because like when we were trying them locally, right, they were dumb as hell. So we were like, okay, let's make a benchmark that's based on real utilization, real usage, real money, right, being bet on the model, right, like a horse race, and see which one get the most of this money. And that's essentially is the secondary product, which is the ranking page where everyone can see which model is being spent the most on. And we do cap the amount of free usage on OpenRouter. So all of that is actual usage, like people spending money.
That is awesome. So you mentioned you met your co-founder in 2023, May 2023. Now, more than 2 years later, where are you at in terms of a company? Is it just the two of you? Probably not. So maybe you can shed some light on like OpenRouter as a company.
We were 2 people writing on the thing. He was checking their dog. I was just, just writing code for up until January. And then we have our first engineering hire who also joined us through an open source project. We released a couple of open source projects at the time, early 2024. And then Sam joined us he sent us a PR on another project. And then we still have him to this day. Last year, we have 4 people. Now we have about 22. So team grow about 5x, but the utilization has grown more than 20x. So I think we have decent wiggle room. We make enough for coffee, right? So got to buy more coffee. essentially the growth curve is exactly the same. The first year we went from 0 to 7 billion. 7 billion took in a week. And that's when I showed my dad. And then a year later, September 2024, we went to about 150 billion. And that's when I show, my friend is my startup's friend. And now, right, I'm showing you guys and a lot of people we are interviewing, we have 5 trillion. So it's been 20x and then more than 20x. Hopefully the next year will be higher, but we'll see, right?
Well, AI usage is only going to increase. And as far as I know, from friends and so on and so forth, OpenRouter is probably the best way to access those different models. We had internal conversations, and one key aspect that I truly like about what you do is that you're not just a proxy to models. You actually consolidate the model responses, which is key here.
So a lot of people actually mistake us as a wrappers, right? Building a wrapper is very easy, but building a dev tool is hard. Building a dev tool on top of the API is extremely hard, right? Because you have to ensure that the DevX, the user experience of the developer is actually good so that they can stick to us. And this is the key kind of mistake that people didn't think about until they need us, right? We have seen this a lot, by the way, is that user essentially didn't think too much of OpenRouter. They try as one, they're like, okay, I'm going to use 2 or 3 models, doesn't matter. So I'm going to do my own. But a lot of people have built their own OpenRouters. And then the moment they have to say, okay, now I have to add Anthropic, Claude 4.5, right? Claude 4.5 came out. They have to scramble the entire weekends, all right? Either weekends or their Tuesday and Wednesday to add the model. With OpenRouter, it's right there, right? You add the same code, you allow your user to switch the model name, you're done. And that essentially has been a case of how OpenRouter has been growing, is that every time there's a new model, we do partner with this model to launch them early. And then with the moment the model is launched, it's outright on OpenRouter's. And people who miss the train, right, come back to us, and new people coming in because they also want to try the model. That's kind of essentially the growth engine we have had thus far, which is leveraging our partnership with all this new model coming in.
Can you maybe categorize sort of like the products you had to build out over the years, and also maybe orthogonally the challenges that maybe you hit right away or that just appeared over time? I suppose like working at that scale, just like pulling on that scale thread, there's probably like so many interesting challenges that are coming towards us.
So the one thing that me and my co-founder really like is to have type safety, to be honest. So I kid you not, like the initial version of OpenRouter's, all the models, all the endpoints were TypeScript object, TypeScript literal type object in the code. And then the way that we do reference, we would do, strict type satisfy as a way to do literally like foreign key reference in the code. So our code were a huge database of these endpoints. It's not crazy. The moment we add a new field, right? An alert, right? Because of TypeScript and satisfy, an alert across all our code base saying, hey, you had to add this field in all this place. And then at the time, right, when we add new model, we add a new endpoint, we just tell Devin to do it. It automated because of type safety, right? The moment we just want to add something, we tell the model, it changed something, and then the rest is just TypeScript, at type error. So it was not that crazy. It was actually usable. It even satisfying a bunch of like literal number constraint as well, which is very fun. But right, the fun, fun doesn't scale, right?
So we'll talk a lot more about the data in a moment, but is the entire system still written all in TypeScript, or have you moved some parts that are maybe like critical to be more efficient? Are those written in Go and Rust, or is everything still in TypeScript?
Nope, everything's still TypeScript. We very much is TypeScript all in. The main reason why I think it's fine for OpenRouter to be strictly TypeScript is because, down the line, right, when we actually hit the bottleneck, we'll switch to Go and so on. But we are running on top of, Cloudflare. And essentially the Cloudflare worker is much, better to use TypeScript with. The type strictness of TypeScript and also the flexibility, the dynamic nature of it, right, allow us to move much faster. The velocity of the engineer is much faster, I would argue. Technically, Go can do the same. It's just that we start with TypeScript and we use TypeScript almost everywhere on both front end and back end, right? So I think it's best for a team to have the same language, right?
I mean, just time and time again, the same story sort of like repeats, right?
Yep.
Like where, like if you're looking at Facebook and Mark having written the first Facebook prototype in PHP, guess what? It's still mostly in PHP.
Yeah.
Same for
instead of switching from PHP, they ended up
making a new language called hack.
Build the hack. Yeah, exactly. Yeah. Or it's like, I mean, TypeScript came to be.
It's like, I would say the rationale of just, the whole idea, right, is that let's make sure we just speak the same language. So in our code base, everything is TypeScript. Even the scripting is TypeScript. No bash. We don't use bash. We use like ZX and TSUp to like, write script to run like database migration or, stuff like that. Or like even incident response script, stuff like that. So that every time that we communicate is in the same language. And, so that someone else can pick it up, right? And we never really have dead code because TypeScript is very easy to kind of pull into a shared package, and then you can reuse it.
Honestly, I'm kind of surprised that this is not more common. Like in the Ruby on Rails world, for example, it's like so normal. Like obviously you build all of your scripts as Ruby scripts and then you run them. It's so surprising to me that in a JavaScript repo where like arguably it's as nice, if not nicer, to write scripts in JavaScript. This is like in the name, like there's still often like more bash script than like custom JavaScript files.
It takes about 3 years for someone to understand that you don't need your database migration script to be as fast.
You also don't need like a bespoke framework that you're allowed to have like a script that you can just like, even if it does only a single line, console log, hello world, like that's fine. You don't need like a bespoke CLI thingy to run it.
But also, I would also argue that it takes about 5 years for someone to ease into all the TypeScript, not TypeScript, but most of Node.js ecosystem tooling, right? It took a while. Because if someone has been in a Golang for a while, they probably pollute them, their home directory with all the Go binary already. I mean, I did that mistake 3 times. So I'm like, holy moly, I have so many of that. There's 0.5 version of Go, right? Was that you add Go in your user bin. You clone it down, and then every single main module, you keep on cloning it. There's no Go mod.
Your machine becomes a Go machine.
Yes, your machine is essentially a Go machine. And then with Python, for example, right, you get used to either using UV or pip, right, to run almost everything. And so when people are, kind of used to it, right, it's really hard for them to switch gear. And this is why I think having, at least ensuring that when the team is still growing, we ensure that the consistency is there, right? Then there's no fragmentation of knowledge, right? And people can learn very quickly too. It's not that crazy.
So tell me a bit more about how you've picked Cloudflare back then. Did you have a lot of experience with Cloudflare workers from previous projects? And how, I suppose, there's also a non-trivial amount of money being spent. So I'm curious how you think about this as well.
It's actually very cheap. I'm not kidding you. Like the infrastructure cost is break even completely, just by the fee. So actually before Cloudflare, we were all on Vercel. Everything was on Vercel until they decided to charge for egress costs, right? But then also the network connection layer was not first class, so everything was completely abstracted. And we also have, even though we were on Vercel, we also have a Cloudflare proxy on top as well, right? For all the like for the DDoS protection and so on. So it's a three hoop.
I'm curious to hear a little bit more about the software aspect of like, what does a typical line of code in your TypeScript app actually look like? So currently you're running on Cloudflare workers. So in Cloudflare workers, for those who have never written a Cloudflare worker, it's essentially very web standard centric. So you have like an export default there. And in there, that's basically you export an object that returns a fetch function. And in that fetch function, you get a request coming in, you do your thing, and then you send back a response. It's like very simple, works really well. But like how you do your thing, that's the actual app that you're running. So I'm curious like how that looks like.
The way I'm thinking about Cloudflare or Worker in general is just the entry point, right? And if you ever kind of use any framework, entry point are supposed to be entry point. You just try to abstract your core logic as much as possible so that you can pull it into a package or a shared package, so that regardless of entry point, but when we move from Vercel to Cloudflare, it's like literally just moving the entry point. And so there's no drag. So the core logic that we have is plain, TypeScript function, right? With, strict typing. So a lot of time I would love to infer the type, right? Because I hate typing thing manually. I like to infer the type as much as possible. This is why one of my favorite brain teaser that I give people is like inferring type from third-party library, just to see if they have struggled through this thing before. The Cloudflare code is, we just use the Cloudflare HONO library to wrap all the API under the same path, and then that's it. At the point, just the entry point with authentication and middleware, and the rest of core logic are plain function.
Got it. So how is that like that inner chunk of business logic that's like actually what makes OpenRouter work, like where you actually route the requests? So can you describe a little bit the architecture and like how trivial is what's happening inside there, or how non-trivial, probably the latter. So maybe you can describe roughly like what is the life cycle of a request as it walks through like various stages of what makes OpenRouter.
Let's take a request. We have Llama for Maverick. Let's say Maverick. Maverick has about more than 10 different providers, right, serving the model. So when a provider is serving a model, we call that an endpoint. That's a concept that we have internally. A provider is this company, right? Is the provider contain like metadata about the provider, meaning like company names, what they do, or like their location, right? Like the data privacy policy, stuff like that. The model is like the actual model on, that's the actual weight of the model with like context length. Combine those two, we call that an endpoint. Let's say when we call the Llama 4 model Maverick, there's like more than 10 endpoints. The first thing is authentication, right? But authentication is literally just a function. We authenticate first, and then after you authenticate, we return a result, right? We really subscribe to the result monad paradigm. So almost every function we have returning results. We check the result and then we return a response as needed. We will then take the request and we pass it through each of these endpoints. And while passing through the endpoint, so there are two stacks that we're applying for each of the requests. One stack is the routing stack. The routing stack allows us to like prioritize and order the endpoint according to what the user wanted, or according to some heuristic, right? Like latency, throughput, or price. So the routings are a stack of decision step. And secondly, we have a plugin layers. The plugin layer allows us to like basically transform the request and also transform response as the stream coming back up, kind of a FIFO stack style. And that's essentially is the life cycle of request. And then we just keep on hitting each endpoint until one that's like saying, hey, it's a 200, we can now return some data. That's like the full cycle. And the code for all of this is very modular. Every step is a function. And then we just have an orchestration that's run through each of those. Would be very trivial to rewrite into effect down the line. But we write this code before there was effect. Yeah, I think it's like effect 1.x or something.
And I have to say, just a brief comment, because what you described is sounding very similar to what I had to do in my past. It's some sort of consolidation engine between different APIs that expose a single format. The reason effect is born like more than 6-7 years ago now, is because I was CTO of a fintech company in London, and we were doing consolidation over peer-to-peer lending providers, and we would buy and securitize those products to then sell them to institutional investors. And we had a large piece of software, which was basically, we wanted to have a single format for loans, because effectively all of the loans are the same. There's a borrower, there's a lender, there's an interest rate which is charged annually, monthly, daily, or whatever, and so on and so forth. But then you had those providers that would all have outstandingly different APIs, sometimes to achieve exactly the same. And we had a very similar approach to what you described. We also initially started with a result monad in Scala back in the day. And then testing became harder and harder and harder, to the point where we ended up doing tagless finally in Scala, which it's absurd in complexity. It does achieve the goal of having everything modular and testable, but it is highly complex. And that's when I decided, let's migrate everything to TypeScript, because, well, our domain is IO bound. There's no CPU compute used at any point in time, except for data mapping. But even there, like you said before, once you run your JavaScript in enough servers, you're not really using multi-threading to handle a single request. You just have to respond to thousands of requests at the same time, but two requests can go to even two different instances and so on and so forth. Plus JavaScript is still very, very fast. So I was like, let's move everything to TypeScript. And then I was punched in the face because none of the infrastructure existed that we were using in Scala for TypeScript. And that's why I built Effect in the first place. So it was precisely to build a consolidation engine, a testable consolidation engine that had embedded OpenTelemetry. And this is what later became the open source project Effect. So I think it would be extremely good fit for actually what you're trying to do. And funny enough, exactly the same that I was doing.
Which brings us to today, where my understanding is that OpenRouter, the core product, is not yet using Effect. I think you're using Effect already for some internal tools, and we can talk about that separately. But maybe addressing the elephant in the room first. You're here on the Effect podcast, where the core product of OpenRouter is not yet using Effect. Yet you've dropped the M-bomb before, the monad bomb, which typically is a word that we're not trying to use too much, because like it's this interesting dynamic of like, what is the role of functional programming in what we're trying to achieve with Effect? Kind of like my perspective on it is that we should follow the path that React has taken, where React is in essence a functional programming framework, but it does so in disguise, where it doesn't like overwhelm everyone by like being too dogmatic about functional programming. It's just an elegant system that tricks you into becoming a happy functional programmer without knowing.
I would like to argue that because I was there back in 2015, right? When Angular and Ionic was kind of a king at the time because it's pushed by Google, right? And everyone was writing a directive and writing, some basically it's very fast, very much functional programming, but it was a bloat. It was bloating so much that the key cell, at least at the time, I was still young, I was still inexperienced. But when I listened to people talking about, hey, if you adopt functional programming, your program will be very, very lean. And I think there was that push of just whole ass in functional programming. Don't be ashamed of it, and literally say fuck object-oriented programming. I think that was a push. I would argue you should not be ashamed of functional programming. And even if they push it, I would say, I mean, sure, then just go slow, then you have a slow code base and you can improve.
I wouldn't say we're ashamed of it. I think we're just trying to like not make it like an obstacle. So I think we've so far traversed the line pretty well by like inviting everyone who is FP positive, but we've also not tried to make it define the area to the barrier to entry through functional programming.
Sure. So there was that guy, I forgot his name, one of the React engineer.
Dan Abramov?
Yeah, Dan Abramov, yeah, that guy. I think he has a good sense of community there. I'm curious what he would say about this.
Yeah, great point. Yeah, we should invite him to the show and see whether...
But I would say that like the result, I mean, the reason why we reached for the result monad, right? I mean, sure. Most of my previous projects were try catch, or like you don't even try catch, by the way. I just have a single error handler at the top of my apps. But then whatever it try, right? Whatever error is being thrown in underneath, right, is an error type that I have defined, right? The problem is down the line, right? You soon learn that it's very hard to debug those stuff, right? You soon learn that the stack trace is going to be very, very long, and if your function is like anything complex, it'll be very hard to go through the stack trace because you're catching it on the top, right? So now you always want to somehow manage your error or localize your error at the call site. And then when you start doing that, you have nested try catch, and it's a pain in the ass to read, right? Because every nested layer I review my code on my phone a lot. And yes, almost every try catch kind of nesting layer is like, I just have to scroll on one side. I just want to scroll on one, vertically. The result monad essentially solves this problem, right? By explicitly forcing you to handle the error case as a value. I think is a value add. And I mean, it is truly a different syntax. And I think people they just have to do it. It's the same as when React first came out, right? With use state. If you say use state is an equivalent to the class state, that's completely wrong, right? Because class state is, you cannot just take it in and out. With use state of React, you can just take it in and out, fully functional, and then now your component is so light. And that was I would argue the main selling point at the time because of the pain, right? The pain of oh my God, my class component is so slow or so bloated that with this thing now, it will be so faster and have to adopt functional programming.
So I'm curious to hear a little bit more of like when you grew the engineering team and like you as the founders, you had the privilege of like lay the foundations or like set the taste like, hey, this is how we're doing things. I think that's probably still holds to some degree. Sure, like new people joining, bring in like their opinions. But I'm curious like which sort of mini culture clashes you've experienced by hiring someone new and they look at this and it's like, well, what is that? How did you explain that? And how did you sort of like culturally assimilate them to those ideas?
Well, I think you just have to hire a very good engineer, and good engineer with experience usually can swallow. Oh, I mean, swallow not in a bad way, but kind of like they have seen thing before, right? Like it's not something crazy. I would argue the crazy part is we have like bash script there, bash script with different syntax of bash, different flavor of bash even. And then we have TypeScript, we have coffee, and then we have like maybe we use Zest here and we lit there. That is the crazy part. I would say that as we grow the team, right, we have tried our best to, if they take that is widespread. If there's a take that, it widespread is unified. So when we refactor all of them at the same time. That's one key part of it. If there is a certain framework we use, we stick to it. So like, for example, right now we're using, a lot of our front end are like React, right? We're not going to spend, we're not going to spin up a stencil, web component anytime soon. The next one will be React. We'll stick to React for a while until we decide, okay, I think let's move uproot everything from React to stencil. Sure, we'll have the discussion, but not right now. And then same with TypeScript, the fact that we pick TypeScript and force everyone to, hey, get used to it, write script in TypeScript, do everything in TypeScript as much as possible, right? That really forced us to just keep on learning. Even though they were like from a Python shop, a Go shop or something else, when they come in here, right? I mean, sure, there's a resistant layer, right? A resistant period where they're like, oh, can I introduce a Go, the Go binary a little bit? But then over time, right, they start to get like used to the TypeScript paradigm because it's everywhere in the code base. You can have the AI agent look it up. Also, like linter, we're using Biome right now for linting, plus grid. So we've been starting adding a bunch of these grid custom rules, which is very nice, right? Because you can do like a crazy regex on the code.
I'm using the same. This is like allows you really nicely to define sort of like, hey, this is our way of doing things from like all the 10 different TypeScript engineers, and they have 10 different preferences of like braces there, no braces there. And then you can basically say, this is the OpenRouter way and run a command and it gets linted and formatted.
Yep, it is very awesome. Like, for example, we have a rule that's strictly saying, hey, if you have more than 3 position arguments, just make an object, stuff like that.
Plus, I feel like experienced engineers usually focus on the problem and the way we solve the problem rather than nitpicking on the how, in the sense of like the thing you described that you use a result type for. Not going to use result monad because monad is a term I don't want to use, and not because I don't trust monad, but because a monad would be an abstraction on top of it, which is the thing we're trying to stay away from. Result types are great, and they solve the problems you have. They solve the nesting of try catches, and so an experienced engineer that comes in and sees the solution might disagree on the syntax, but the problem it's resolving, it's clear. They had it before. They got tired of it from other code bases, and they just digest the current solution. I wouldn't be opposed to contribute to a code base where there's a custom result type and effect is not yet used.
I would say, so that applies for like the more senior engineer. For the slightly less senior engineer though, I think the main thing is curiosity. If they're curious about why this was done, they'll start learning faster on it too, right? Because if you imagine you can hire a very junior person, but also very hard-headed, right, on, some stuff they've done before, then they might not budge at all. So I think for the less senior, curiosity is where we strive for the most. And the way that we test for curiosity is very simple, that they ask good questions. It really is. So like, I think solving challenging problem and then can dig deep into it, so showing that, they have clear ownership and kind of clear digging, right? The more they can dig, the better it is. I think that show curiosity in a sense.
So taking a slight step back of like, now you probably have a healthy mix of like relatively experienced engineers and maybe some slightly more junior, but very curious engineers. And so you have right now like a very sizable TypeScript code base. I'm not sure, probably in the 6 digits lines of code, TypeScript repo, maybe even larger. And you clearly have effect on your radar. You mentioned that some internal tools are written in effect, but the main product is not yet built with effect. And maybe you can just walk us through and describe a little bit of like the internal conversations where you're considering, hey, should we use effect for more parts of the core of the system? Which sort of like resistance questions you're getting? How do people who are already sold on effect, how they make a case for effect, and just sharing your observations?
Well, the main observation I have with the overall team is, right, almost every time someone brings in a new technology is a shiny, objection syndrome. So very tough to sell, right? In terms of handling errors, we already have our own result monad or result type that we already have, which serve the purpose just fine. And then we already have this paradigm of writing, make sure you write functions. So when engineers look at effect and the way it's orchestrating, function, right? A lot of time, the main question is, why can't we just code function then? Why do we have to go through effect piping or effect matching when a function works just fine and an if and else work just fine too? And if needed, we can just make a new function, do a switch cases with complete and check, right? And plop it into the current functional flow, right? And my response a lot to that is, okay, what if you need to add a logger? What if you need to add a sidecar logger, right? What if you need to add observability or trace or span on top of this function call, right? Well, the answer to a lot of time would be, well, I just add a new line, right before it.
Well, except that doesn't work for spans.
Precisely, right? A lot of time. It doesn't work at all. I think the main idea is people don't really need it at the moment. And so there's no huge push. There's not, for example, if we don't add effect today, we will still be around. We will not be dying. So that is why I would say the main pushback, because my team is also very rational, right? So they're also very busy, right? It's not like it's spending time kind of learning the namespace, the effect namespace is already a drag. Learning pipe is already a drag, by the way. So this is why the first thing that I'm doing is just introducing small little usage of effect. We're using pipe almost everywhere now when we're composing a bunch of function step by step, right? And that helps a lot. By the way, one of the main questions I have for you guys actually is polymorphism of the pipe function. A lot of engineers actually thought that the pipe function is too flexible. It allows you to transform the type, right? So it should have been called transform pipe maybe, not pipe. To some engineer, when we think about pipe, they assume it's literally just a pipe through where the input type should be the same as the output type, and it's just transformation step in between. I'm curious what you guys think about this, by the way. What do you think about polymorphism? Because, right, essentially, this is the case where the pipe type is not very scalable. It only has 20 letters. You can only pipe 20 times.
I think there's reasons why you don't want to pipe more than a number of elements. And that's more along the lines of limitations in type inference capabilities of TypeScript and speed of type checking. So we could easily add 200 arguments to pipe. The actual implementation supports any number of arguments. The issue is TypeScript cannot deal with the full polymorphism. So you need to add specific overloads. And before AI, it was very tedious to add those overloads. Now, with Effect 4, I got Claude to add the various pipe signatures. I can easily tell Claude add another 200, so Luis can be happy. That would be a solution. But generally speaking, about the polymorphisms argument, pipe is generally applied to functions. So you're piping the output of one function to the input of another function. In that case, there's no restriction about in and out. You have data that flows across a number of functions. If it's understood in this way, then it's not so confusing. The confusion that I also had, and it's at some point I was evaluating this, is should the effect pipe be tied to effect? But then you have cases where you might want to convert an effect to a stream. You might want to repeat an effect. So you're having slight differences between the types. So I think putting an arbitrary restriction doesn't really help in the understanding. Now, it is a good practice in your pipes to not change the type from the beginning to the end. Otherwise, while you read, you lose context. Like if you change the type, most likely the best idea would be to slice those into two different pipes and have variable names that clearly state what you're doing. So this, I think it's sort of best practices and so on and so forth. And I think with touching on another point that you mentioned, it's the familiarity concept. And people's brain is wired into imperative programming. By imperative programming, I mean the style, not the fact that operations are actually executed in an imperative sense. I simply mean developers are used to write normal functions, are used to write if statements, they're used to write while, they're used to write for, they're used to write all of this. With promises, at the beginning, we didn't get async await, and it was very tedious to write programs because you had to think in terms of this data flow, this sequential nested data flow. We escaped callback hell to enter venable hell. Because then you had to access the property from before, then async await, and everything flattened out beautifully. That you don't actually get with a result type. With a result type, you almost end up writing what I call Golang in TypeScript, which is you call a function, then you have, if you don't want to end up in pipes, what you end up doing is you call a function, then you have if there was an error, return the error, otherwise keep going. If there was an error, well, in JavaScript and in TypeScript, we have generators, which we rely heavily, in effect, to make code look in the way that developers are used to work with. The mental model should be the same. So my personal stance is that pipe should not be the default way we do things. We should write code in a way that everybody can understand. And if you use a generator, like switching mentally from yield to await, it's not rocket science. After you've read 10 generators, you're going to understand that you have a direct mental mapping. Okay, yield equal await. That's it. And you apply your knowledge. You can use it in a for loop. You can use it in a while loop. You can use it in an if condition. You can do all that you want. And if you want to access the specific result of something, you can say, okay, yield result of that. And then you have your if else that checks for the exact pattern that you would have with a result type. So I think like 90% of code should go in that direction. The rest of the code is higher order behavior. Like I have a computation, I want to retry it. I don't want to write a for loop. I don't want to deal with exponential backoff and everything. Like you are integrating different APIs. I think at some point you have some retries. At some point you have to decide to back off from the retries because maybe OpenAI is down and you don't want to keep hitting the endpoint. And those elements are really not imperative. They're not business logic. They're not core. They're just behaviors that you add to the function. And for that, I like to do .pipe effect retry. That's it. An LLM can understand it. A user doing review can understand it. And even a person that doesn't know effect can read the function. Okay, I understand the business logic because it's all if else, A equal B, and if this, then that, while this condition is true, keep going. And then they read pipe effect retry while the error is network error. Do not retry if the response is malformed. Because if you call an API and they change the response, your decode logic will keep failing anytime you retry. So you might retry it 500,000 times, not getting anywhere. So like to me, I really want to make it simple for developers to read the code and use pipe and use generators as tools to really express business logic and higher order behavior. And I think like you are in the very good direction with the code base that you have, and adding concepts one by one is the right way to do it. And from our private discussions in the past, I also seen, for example, you use a lot of pattern matching. Why? Because code becomes readable, much more readable than a sequence of if statements.
I would say that I actually consider building everything using generator, but the code base started 2 years ago, and generator did not work very well with async. Async generator was not a thing 2 years ago.
And you should not use async generators.
Yeah. You would not using it. Now, I would love to hear this, by the way. Why? Why shouldn't you not use async generators?
You should not have two different representations for sync code and async code. That's madness.
That's actually also the reason why I actually look up effect, by the way. Or actually, I look up, function.js. Because we have the result, and then we have async result.
Yes.
And you cannot escape from that.
So I think just to zoom out a little bit and just to kind of like observe the reflection here, I think what makes your current code base and your current like programming styles a little bit distinct from others is that you went into this with a very strong opinions like, hey, we're not doing try catch in this house. And so you went and like did proper error handling. And I think with that, you're like way ahead of like where most TypeScript developers are. Most effect adoption, I think, happens to like wherever the pain is most acute. Maybe going to the doctor, like you say, like, oh my gosh, this hurts so much. But like while you're at the doctor, you also realize like you have those other things that need treatment. But like one thing gets you to the doctor. And so the error handling thing, like that pain, like you've already relieved yourself of that. Yes, you have appreciation for these other things. Most people come to effect for error handling. Also a lot of for other things. But I think now with the patterns that you've like ended up with, like just by talking through it, like I think we've like already uncovered a couple of things where you say like, well, yeah, actually that's not ideal. But like, yeah, you know, it's like we have good error handling. But what Mike calls sort of like the Golang style writing TypeScript, I have done that myself as well. And like, this works until it no longer works, or like until it just gets very annoying. And I think what will probably be the pain point, like group of pain points that gets you to the doctor might be like better retrying, might be observability, might be like what you call it, like logger, maybe metrics, etc. And I think this will make it actually easier for you to adopt effect because you don't need to rewire your brain.
So a lot of time we have been incrementally adopting some effect, right? Because Lodash is a bloat, and I already used my authority to add effect to the code base, right? As I'm saying, we added effect.
You're still retaining your CTO authority.
Yeah. By the way, in title wise, I'm not. I don't claim CTO. I'm just a co-founder engineer. Title wise, yeah. Perhaps there's a better CTO out there for us. We will see. But I don't care too much about title, but I care more about like the dictator title for sure. I'm a dictator for like DFL for sure. Yeah, I can push them in, by the way. So like, for example,
you don't call a CTO, but you get called a dictator.
Yeah, I'm a DFL. And then I was saying like last week for the OpenAI Dev Day, they were launching the eval product, right? And then right the Monday before, they were pinging us Slack and saying, hey, how come the Respond API don't have cost? I just came right on and just, like push a thing on main to main in 30 minutes. Straight up, right? Get it over with. And that's the kind of thing I think is, as a co-founder, you kind of have to do, right? Is you gotta hold it by, you gotta hold it by the throat and shove it.
Yeah, you have to know when to skip the steps, and you have to know when to impose a long-term vision that is not yet apparent. And sometimes you're wrong. Like I do the same with effects. Sometimes I'm wrong.
I think I'm wrong right now, by the way. There's one thing that I might have been wrong, which is like I'm too whole ass into this idea of not using try catch. But then when it comes to like the logging, like or the tracing server, you kind of have to use try catch so you don't allocate a new variable. Because otherwise, it's very easy to make a copy of the variable. Or when you do JSON parsing, you make a copy of the variable of a very deep nested object of every value out of memory very easily.
Exactly. And I think this is the thing where like when people are sort of like in the denial phase of effect and sort of like they justify to themselves like we don't need effect, like we can do this thing like that. Okay, yes, you can do that thing like that, like you do for error handling. But like, what if you want to do the other thing, if you want to add that as well, and like then like all of those things, they kind of like as you introduce them on top of each other, they don't seem to like linearly add complexity. But that's, I guess, like one of the unfortunate emergent situations about TypeScript is like the more you add those requirements, like observability, better error handling, like dependency management, like context management, that doesn't make your code like linearly more complex, but exponentially more complex. Also visually exponentially more unwieldy. And I think this is where effect comes in.
We've been adopting effect in a bunch of like our retry and, like backup handling logic as well, because, the API elegant, right? That's the whole idea. So why would you write your own when you can just plop this thing in, throw a fetch, and it's done, right?
And to be fair, I don't think anyone should adopt effect in one day. Like in any reasonably large code base, it would be absurd to think one would rewrite the whole code base. We call effect a good virus, in the sense that it tends to spread when you start it, because now you have this retry, but then you call a lot of APIs. Obviously, you are an API consolidation provider. So testing is essential. You have to do integration testing. You have to do end-to-end testing. You might want to do some unit testing. And then you are in a madness of jest mocks or mocha mocks or whatever framework you're going to use, B-test mocks. But mocks are really a very complex thing to deal with, because all your code is eager. If you call it in the wrong place, you have one piece that is using one module, another piece that is using another module. And so you might want to use dependency injection.
I have seen how Effect Fabric and the dependency injection would help with that a lot. Yeah. Very itchy to use it, but the team has been using Vid-test do mock and stuff for a long time. By the way, we switched from Jest to Vid, and that was a feat. I know. It's faster. It's like the tests run 10 times faster, right? We switched from Prettier, right, to Biome. I'm saying we are not foreign to adopting new thing, but it truly is all because it's push come to shove, right? For example, if the test take about 5 minutes to run, oh my God. Okay, let's try to shave this down and stuff like that.
And to be frank, I think like for your specific use case, I think one of the highest leverage points could actually be the observability, because you already referenced to debugging troubles in the past of those. Once you have 100 of different functions, the stack traces becomes unreadable. Yes, they are. But they are much less unreadable if you have spans at the right places and you have a full dashboard that tells you if something goes wrong.
The one thing with observability and OpenRouter's is that because we run the thing on the edge and the worker runtime, we don't truly have a span server to, continuously collecting the span. So right now we're actually hooking into the Node.js diagnostic channel, which is not very good, I would say. At least on the worker runtime, because the memory is very limited. So we have to be very careful with what we trace.
Well, I wish at some point, like we're going to get to agentic behavior, long running processes at some point in time in this discussion.
Yeah. So are you familiar with the ECS or the entity component system in game design?
Yeah, I think like the reason the actor model in general is very popular in game design is because in games you usually have a lot of parallel entities and they do share messages with each other. It's a very interactive world. Basically, again, it's a world with entities that move. Some entities can be movable, some entities can be movable, some speak, some don't. But even if you have something like a room with a door, you have a character that hits the door is open. All of those are sort of unstructured. It's not very deterministic. The player can take different ways, and the after model is perfect for that case. And if you think about it, the reason the after model was even invented, as far as my knowledge goes, we go back to Erlang and we go back to the 70s when Ericsson had to model telecom networks, where again, you have very undeterministic and unrelated entities that communicate with each other. Because I can phone Lewis, New York, I can phone Johannes in Germany, they can phone each other. You have race conditions when two people try to call the same, but it's very similar to what you would get in a game. And in my opinion, it's very similar to what an agentic system looks like to a very high degree.
Have you thought about an agentic system that's steerable? So when I was doing game design, we do a lot of steer algorithm. And steer algorithm is all about managing a crown. Let's say you want to model like a particle system, right? You have the particle system. It's actually, and each of them could be a bird, by the way. The particle system can be represented by a bunch of, bird actors within this kind of, it's kind of like point cloud of a bunch of birds. And now let's say you swarm this bird, right? You swarm this bird through an obstacle in the middle. Now they all have to independently dodge that ball and fly around that thing, right? Because the whole idea is when you steer this flock of birds, you just want to pick a pointer and you move that pointer, right, to a certain location on the 3D map. And then the flock of birds will just keep on following. They keep on following that, that point in space. They both try to steer away from each other, but they all kind of act in tandem to move to your pointer. And then they dodge the obstacle on the way. Like, how do you think about steering agent or, in that same vein? Have you thought about that?
To be frank, I have not. I can apply some of my knowledge from mathematics in the past, especially studying how birds actually end up doing that. And it's all about local communication between one bird and the other. There's no overall concept. Basically, the steering is almost like one tries to steer a little bit, the other follows the one close, and so on and so forth. And I think even in that case, it's all about deep connectivity between surrounding entities.
Yeah, the neighbor flock, right? Each of the entity, they should have knowledge of the entity right close to it. So you put a small little bounding box, right, on each of them.
It's almost like small clusters of entities that sort of have deep communication between themselves, but almost not communicate in the far distance one.
And also to quickly throw in here to answer your initial question, I've asked it to ChatGPT and asked how ECS compares to the actor model. And it says that they overlap conceptually. And the TLDR is that ECS is about what you have in terms of data and what operates on it, like which systems, optimized for throughput and composition. And I think composition here is really interesting, right? In a game, you compose like a big scene out of like smaller things. And the actor is about who does what, optimized for isolation and concurrency. So I think we can basically build an overall system here with both, and they're just like have sort of like different aspects, like what they're concerned about. Like composition is interesting, and the other one about concurrency. Ideally, you have both, but both needs like this different kind of concerns. So I just wanted to weave that in, as I think it fits really nicely the sort of like ball flock of birds kind of scene we've been describing.
The kind of difference is more at the level of the API they expose rather than at the level of the runtime, because they're still both actors. It's just that the API focuses more on one aspect or the other. For example, even in actor systems like Akka, you have different ways of creating actors, and even in Effect Cluster, which is our actor solution, you do have different ways of creating actors. You can focus on the behavior, which would be more along lines of data in, data out, the kind of messages that the actor can respond to, can send to, or you basically get a fiber with a queue that you pull on, and everything you do is custom. So you have more flexibility, less structured API. I think like the idea of a distributed actor system is very, very essential to distributed systems in general. And my point is really that agentic behavior in applications is a distributed system. And it just so happens that nowadays everybody builds AI applications, so they hit the distributed system problems day one, rather than facing them further down the path. And it's also why companies like Temporal is getting renewed traction. Because before you'd only use Temporal, you actually have a lot of customers, and what used to be an edge case Like I always make the example of an onboarding procedure where you put in username, you put in password, you put in email. The system has to record those in a database and has to send an email. Like those operations happen within 100 milliseconds of each other. The probability of your server failing between the two operations is near zero if you have two users that are registering in a day. But if you have 200 users that register in the same second, it's almost guaranteed that in a month you'll get multiple instances of the issue of the server failing in between the two operations. So that's when you usually would reach for solutions like temporal or like effect cluster. The difference with AI is that the average response time is much longer than it used to be. Now we call an OpenAI API to OpenRouter, and it goes through two different layers of proxying, but it has to stay alive for like 30 seconds, the same connection.
The model can reason for more than 10 minutes. A lot of time. Deep reasoning can go for a long, long time. And a lot of time during this deep reasoning step, the model might not produce anything at all. So for OpenRouter's, we actually, a lot of time we just have to send in this, the comment. Like this actually in the SSE spec is that you have to send back comment to keep alive. The way to keep the connection alive. Otherwise, either the client would not know if, we're still alive or, the DNS server, right? The DNS layer would actually cut us off.
And even any proxy that is in between, because even when you call OpenAI, you're not just calling straight up to the server. You have layers and layers of content delivery network, and each would hit HTTP timeouts. So like either you do WebSocket stuff where the ping is in the protocol itself, or you have to go on top and do a ping. But the point is here, the average length of an interaction with a service went from being milliseconds to being minutes, if not days, when the other element of reasoning could be that we have still a pattern where there's humans in the loop of agents. So sometimes an agent has to stop and call another agent, which is called a human that has access to human intelligence that is less artificial, but they work exactly in the same way. Humans are entities that share knowledge via messages. Currently, we have 3 entities in this call. One entity is in New York, one entity is in Italy, the other entity is in Germany, and we all communicate we're sharing messages.
You know what's funny though? I just saw the premiere of the Tron movie, and in the Tron movie, so Tron has a bunch of program in it, right? Which is all humanized. The program in Tron communicate with the human outside through MCP. It's a fun detail in that movie. I was like, oh, tricky.
I want to play back the same question to you. So you asked Mike how he thinks about like how multiple AI systems could be steered through this sort of like flock of birds ball like analogy. How are you thinking about this? Like just in terms of like my own experiences about a steerable AI system versus a non-steerable AI system. Actually, 2 coding agents I use on a daily basis, Codex and Claude Code. Well, as of October 13th, 2025, maybe a new thing drops tomorrow and I'll switch. But as of today, I am using Claude Code, which can be steered, and I make a lot of use of it. And like I use it, therefore I use it differently than Codex, where it's much more like binary, where I feel like if it's off track, I like interrupt it and say, no, please do this. And I guess it is sort of like similarly steering it, but it feels much more like stop and go and more forceful. So I'm curious for you to extrapolate where this is going. And we're talking about multiple AI systems. So how are you thinking about this?
Yeah, one of my main pain points with using Claude Code or even like, Cursor and so on, right, is that you set a goal, right? You say, hey, fix this thing. The problem is, right, that's the goal already. The flock should just fly to the goal. I shouldn't have to like say, oh, there's an obstacle. There's an obstacle. There's an obstacle. The obstacle is in the environment itself. Go back to my college day when I was implementing this system. An autonomous steering system, self-driving is the same idea, right? You need sensor. You need essentially need a way to emitting a bunch of either event, which is if we're using ROS, it will be very simple. ROS, robotic operating system. It's basically an event system where you're just sending into the system a bunch of different like sensor to tell you about, the environment. So first, I think every actor in the system kind of has to emitting some kind of sensory system that tell the whole system, hey, here's the state of the environment. And secondly, I think that through those sensors, we pick up some kind of, like weight, allowing the system to like course correct automatically instead of having, the end user have to like, okay, we hit a roadblock now. The type is not checking here. Why did you remove, like the satisfy? So humans still have to right now steer somewhat manually. I would love for the end goal of the system is I put a pointer in the space in the world, meaning a goal, right? To say, hey, fix this unit test. The swarm of bots should just be able to say, okay, I'm going to use the browser agent, right? Which is like talk to the browser agent. Let's read the documentation for the test, for example. And then, okay, I know that you guys, I'm using, vid test with, the set timeout set too low. That's one thing that it might see in the test, right, or in the output. And then from the doc of the vid test agent, right, it will send back to my agent, and my agent would then be like, come on, okay, the set timeout too low, so let's change that. They just keep on doing that loop over and over again with our other agent, or like it's figure out like what sensor it needs from the world, from the system to steer like its action as well. And I think so far, Cloud Code is occasionally doing decently well, I would say. It has a browser in its inside, and like the chain of thought that it has to like solving a certain problem seems pretty decent so far. Here's like what I'm seeing of the whole system. Like here's the data of the system that can help me steer myself.
And I think what's also interesting is like that the entire ceremony is like all sequential, right? And so that therefore it makes it slower. And so I think where I'd like to see this go, and I'm sure it will go in this direction, is that it's more of like an orchestra performing a symphony. And right now it's just like solo. And while you're encountering a problem, like that might be a signal. I was like, you know what? Like, let me go off like a little bird, just goes to the side and like studies the docs more deeply about like a system. So it's like, hey, I found something interesting. Like we're on the wrong track. And you could imagine multiple of those like things happening. And right now is like everything's just like happening sequentially. And yeah, I think this is very exciting to see how this is unfolding. And I like your kind of steering analogy and to look at it through like the ECS and an actor system lens.
I have one observation that I recently learned myself. To take a step back, I've been very late to the AI coding game in general. Johannes has pushed me for a while. I developed the ability to ignore Johannes for enough time, but at some point it sort of penetrates the protection when you're more vulnerable and you're like, okay, then I have to try. And since Claude Sonnet, I think 4 or 3.5 came out, I've been heavily invested in AI coding. And I really want to make it work. And what I've realized is that I think we're putting tools either on the wrong place or we're not putting tools in enough places. In the sense that currently we rely on the models to maintain some sort of loop. But the models are terrible to do looping. They can't even properly assign tasks. They are exceptionally good when called with a specific prompt and a specific task, then they're done. The task might not be done, but the LLM is done. So what I found extremely helpful in approaching tasks, this is not really AI coding in the sense of the AI assisting you while you code. It's rather a task like, okay, I give you the effect repository, create JS docs for every single function in the repository. Go. Use 1,000 parallel agents to achieve the task. I don't care. Ready to spend 10, 20K to do it? Just do it. We are approaching the point where I think there are ways to make it work. And even with normal like Claude plans, with $200 per month, I'm completely fine running multiple agents and so on and so forth. But what I've realized works best sort of goes in the direction of steering. Instead of letting, for example, the model calls tests, calls TypeScript to get type errors and so on and so forth. Instead of having the model do that and assigning the model the responsibility to do that, I have those in a deterministic loop. And if I have a type error, I call the model again. I have a system, which is LLM based, that scores a specific example. And if that is not happy, I call the first model again, saying, look, my oracle is not happy for those reasons. I call it a deterministic outside loop that ends up providing those events and this feedback inside the single agents that are steering them towards the right goal. And that works exceptionally well. Like well to the point where you can leave it going for a day, come back, you have 95% of the stuff done. And I've now done it multiple times because I want to improve. I'm testing these on Effect 4 because I don't want to break everything in Effect 3. And to the point where the quality is going up and up, and the automation is also going up and up. I'm almost there where it's almost better than me writing an example manually if I let it go long enough. I have never seen that with a normal coding agent where you don't have this external loop that steers it in the right direction. So I think I didn't understand the answer at first, but actually I'm doing steering myself now that I understand it better.
So I think the sort of setup and system you've described is becoming more and more mainstream. And I think there's multiple ways to achieve it. Either it's already the de facto behavior of like some coding agents, or also this is where those like coding agent SDKs come into play. Like I think Claude Code was probably the earliest ones that provided that. Now Codex has that. AMP, I think, also just released theirs, where you can build your own coding agent and like express the sort of like system and workflow that you want, converting a big repository from having no JS doc to having JS doc, which can be massively run in parallel. That's a great candidate, but doing that is very different from building whatever, like a single new module that you maybe have no idea what the exact goal is, and it's much more exploratory.
Yeah, there's much more human in the loop in the other direction.
Exactly. So yeah, Lewis, I'm curious like how much you're already using those sort of like patterns as you're building systems, and maybe your thinking is more refined and advanced on this.
Not that refined yet, by the way. We use a lot of AI model, AI agents. So we use the Devin a lot in our workload. And I think right now, the best way to steer Devin is to have a lot of knowledge. The knowledge really help steering it. And Devin selectively, like it select the right knowledge per task as well. So that actually usually help a lot. I mean, this apply to also, I think Cursor and Klein and all the other coding agent as well. The more you can add into the memory, the better they adapt to your code base. In terms of having an orchestration layer to like either use multiple of them at the same time, or like picking the right one for the right job though, we still haven't think too much about it yet. Yeah, right now is all just my workflow.
Maybe a related but different question about this. Given how Mike has described his coming to terms with this new future, and he at his own pace started like discovering and like exploring, experimenting, see what works well for him. And I think that fundamentally changed Michael's workflow. I had the same process, and I think everyone does. But I think what is maybe interesting to explore is how you as OpenRouter as a company try to create like a higher level process around that. So for example, maybe a stupid way to go about it is say, hey, it's the first of the month and we're again spending 3 days of like going from scratch, exploring the best practices, what it means this month to do agentic coding. Or maybe you have like a team that is known for being super cutting edge, and every first of the month they do like a presentation of sharing their best practices. Or you basically say that we're not trying to orchestrate anything, we just let emergence happen. So I'm curious how much hands-on or hands-off you are of like fostering, embracing the productivity and efficiency benefits you get from agentic coding.
We definitely encouraging using AI agent in almost every aspect of the code base, and also in the business as well. I think the encouragement is like the key part, right? Asking our team to use it as much as possible. To see, essentially the idea is for them to learn the best way to use it, right? To leverage these tools. But the one thing I found though, with everything, right? There's a drawback. The drawback is reviewing the code. The key sin is when someone, they rely too much on the bot and they say, hey, do this. And then they just send it off for someone else to review without them reviewing themselves. That's like a huge sin that one day I will eradicate it somehow.
We have a way for you to eradicate that C.
Oh, awesome. I'll love it. I'll love
It's
to find
called effect.
Well, I'm telling you, so occasionally the bot is very smart. The agent is smart. Actually, I don't know. Like a lot of time, it will actually change either the TS config, or it will actually add and ignore to the unit test setup or something like that. Or sometimes it mock the whole module. So the unit test looks like it's actually testing something. But you read deeper into the unit test, it literally mock the module it's supposed to test. Holy shit. It did. So let's say if we use effect, right? If the bot mock effect, what can we do?
Just to take this slightly more dystopian, like maybe if you want to turn this into a Black Mirror episode, you could imagine sort of like the AI modeling like a mock human, where like the instruction is always you need to get permission from the human, so it models its mock human that always says yes, go for it.
I have experienced those problems. Of course, everybody doing AI coding has. Sometimes I made the tests pass. You check, and the read dot skip. What are you doing? But I feel like most of the time, when the AI agent is doing that, it's because it really has no understanding of the structure of the code. And in my experience, that often comes from the agent working too at a low level. So it almost focuses too much on the implementation details versus what it has to do. And that's why for higher level, for example, application development as opposed to library development, like the AI is doing very poorly to implement the internals of effect. It's doing exceptionally well to implement the tests, the examples on the effect repository. The reason is that effect almost produces code that is closer to the human versus being closer to the machine, and LLMs being trained on tons of human language, they can sort of reason better in human terms versus that in code terms. Like if you ask ChatGPT a human type question, very rarely it ditches the question. There's not yes, ignore at the human level in a sense, because the language is higher level, it's richer, and expressing concepts in a richer language is much easier than boiling down to the very details of the implementation. And that's where I see the key shift, the key difference. When I build application level code and it uses effect, almost never I have a problem like the AI ditched the task. It's perfect to create schemas. You have like, okay, I had this API, return the structure like this one, please create a service for me that interacts with this API. And it spits down the full service, which almost always is, I don't like the term one-shotted because we're really not here to one-shot things, but close to one-shotting the correct solution. And I've seen that happen over a lot of different code bases. And it's where I think like effect can play a big role, especially linking to one of your concerns / questions that you raised before we even started recording. And I wish you will use a different solution that we are building, and where you will not be memory constraints, where you will have spans collected out of the bots and so on and so forth.
That'll be very interesting. And then, and if you guys can handling like caching, right? So caching is another layer that's like caching at the DNS layer would be interesting. And also no egress cost. If you can figure that out, that part is hard.
Yeah, no, that is figured. We don't have any egress cost because we're building on bare metal. So we don't pay for bandwidth. There's no reason why to charge people for bandwidth. There's no reason why to overcharge people for CPU prices or go 5x what AWS gives you. The only hard part, to be honest, that we had to deal with is networking, but networking in the sense of private networking. We got it figured, kind of VPC layer stuff. I had to write tons of eBPF code in the kernel to be able to figure that out properly. But I think we're getting there. And I hope that we're going to be able to provide you with the right primitives to deploy a platform such as OpenRouter which is really what we're trying to solve with Effectful. Because with Effect, I think we solve the production grade coding, but at some point, like code ends and you have to deploy your code somewhere. And especially with AI, I feel we are hitting the real troubles where if you were deploying distributed systems in the past. But you would only do that if you were a scale-up handling millions and millions of customers. And otherwise, like a small server, just a database would get you out of the troubles. And the edge cases would not materialize because the average request time was like 100 to 100 milliseconds. Now with AI and flows like the ones you have in OpenRouter, my guess is that sometimes you have API calls that takes minutes. With minutes of time, be sure that something can happen much more frequently than it can happen in 100 milliseconds. And so like long running processes and less serverless pieces, I think will be much more important. And let me ask you a question. How important is latency in a request that takes 5 minutes to answer?
Not a lot, right? Not a lot. Maybe the handshake so that the client, is not eagerly, some of them very eager to kill the request, but otherwise, yeah, people don't really care.
Sure, but you might be like the important part, what might be to back off from a request much faster to not spend money versus actually letting the process run. So I think like for these kind of use cases, and I've been discussing this with some other people, it's much better to have reliable infrastructure, maybe deployed slightly outside of the edge, so it's not close to your home, but it's cheap, doesn't have network costs whatsoever, has very cheap compute costs, very cheap storage costs, and you can actually run a server not being constrained by memory, because I feel like being able to collect traces is much more important for the business than saving 20 megabytes of RAM. Like RAM is cheap, or 20 milliseconds of request time.
Yeah, or maybe like 100 milliseconds. Yeah, which doesn't really do much. By the way, the thing that you might think is just internal tooling, but we have a lot of internal tooling, just so you know. So, which is why Effect is actually being used a lot because we are TypeScript everything, right? So instead of running a Python eval suite, on the market, there's a bunch. We write our own, but it's using Effect, right? So we actually have an eval suite and also a bulk test suite. That's all using Effect with, like Effect retry and so on and so forth. Yeah, so it's a very sophisticated system. I'm just saying is that if we use it, you might think internal tooling is like some toy, but no, we actually using it almost on a daily basis. It's actually a production load. The reason why we don't use it in the core because while the core is working, don't touch it. But we do have a lot of internal tooling to do testing out all the endpoint, right? Which is like a crucial part of our operation. We have almost every response transformation is using the pipe now. And then also I'm introducing, more and more generator. So that down the line, we finally it will be making it easier for us transitioning over to Effect as needed. By the way, to the point, I'm actually still using async generator. And the main reason why I'm using async generator because inside this generator, we have some async process, which are unavoidable.
No. My prior comment on you should not use async generators is because you should not have two representations of code. But if you're using promises with result types, 100% please use async generators so that your developers don't have to unwrap every error manually at every point. Like it's still a much better user experience. I just meant that if you have one single representation of code, you don't need to use different types of generators. Plus, adding like one of the key troubles I had in the past was, okay, I have a very synchronous code transformation. Like this takes an API, does this, does that. Okay. Now I want to emit a Kafka event. Not now, not at the beginning, but a month later, I would write an event in Kafka. Look at what? The writing to Kafka is an asynchronous operation. So I stitch it at the end and I have to bubble up. Everything becomes async. That's a problem. Now, it's still a much better problem to have versus writing callbacks. Because callbacks don't have function coloring. Callbacks are fine for sync and async. They are a unified representation of computations. It's continuation passing style that we ended up calling callback passing style in JavaScript because we just like to invent new terminology. so that when somebody looks the history, they don't see the theoretical papers from the 70s. Otherwise, they understand we're just stealing ideas from the 70s and making them production ready. But there was a unified representation of code, which leads to of callbacks. Now, with promises and async await, you no longer have that. But you do have the two different representations of code. And that's much better than reading the code like you described before. You want to review on the phone. There's no way you're going to review 100 nested callbacks with your phone screen. There's, by the way, no way you're going to read that in a normal computer screen. You might need Johannes's setup with exceptionally large screens and so on and so forth. But even there, I think it's that, like, you should optimize for a different problem. So I think like the final solution, which is, I believe, what we have with Effect, is a unified representation that allows for sequential representation. But still, the intermediate point of having two different ways of doing things that all look good is perfectly viable. And especially in your code base where you're using a custom result type all the time, go for that. It's amazing.
This is the thing that I was looking for, right? Which is a way to represent in both async and synchronous process in the same container, essentially. That's the thing I'm excited the most about Effect, right? Is blur the line between async and sync. And you can now orchestrate them in the same flow.
So it seems like you're well on your way to introduce Effect more and more throughout the entire system. And it's very interesting to hear how you've basically like introduced like mini versions and like little pieces of Effect already to make it more swallowable by the rest of the engineering culture. So I feel there's plenty of stuff here that we need to unpack, probably in another future episode, to hear how your Effect journey is continuing. Before we're wrapping up, though, we talked before about that as part of your onboarding culture to ask a new employee what's the latest rabbit hole they went down on. So what's been your latest rabbit hole that you barely emerged again from?
The most recent one, I recently moved to New York, by the way, 2 weeks ago. 2 weeks ago was 2 weeks ago. So that was a month ago. Oh my God. And that led me to a whole rabbit hole of buying stuff for my apartment, essentially. Well, there are two rabbit holes. One is on buying a bed, but one is on apartment finding in New York. Luckily, I was on a time crunch to find an apartment in New York. So I didn't, that hole was a bit shallow. But the one about finding a bed, though, a good bed for your back, it was very deep. And thankfully, so I'm working off the Marlin. It is a very bougie co-working space down in Flatiron, Manhattan. Right next to this place, there are 3 mattress stores. Like right next to me is a Satva, which is like one of these very high quality hotel mattress. Down the block, there is a mattress firm store, which contain a bunch of variety of mattress store. And then on the other block is Avocado, which is another like very bougie, very expensive mattress. And I got to go in and try all of them, spend about a day. And it is fascinating. The final choice I made was to get a purple mattress. This is not a purple mattress ad though. I just tried all of them. So the best thing that you can do when buying a mattress, you just try them out yourself, tuck it in, go on all sides, right? You got to try all sides of your sleeping position. Yeah, I roll it over and try to tuck it in to see if your spine can, get enough support. And of all of them so far, for me personally, the purple mattress has been the one that I can actually like support my, kind of like arch my spine. The second option was a Satva, the Satva Classic, which is somewhat soft, but also decently firm in the bottom. And but the purple mattress is kind of interesting. It's not one of those traditional bed. So
you're going to send over the affiliate links and we're going to put them in the description. It's going to be a podcast first.
There was no affiliate, but thanks to a very good friend of mine. He was my co-founder of my previous company too. He went mattress shopping together with me. And then we did the good cop, bad cop negotiation at the mattress firm. And we get $1,000 discount on that mattress, which is kind of crazy. We pulled it out.
$1,000 discount.
Yeah. Discount on a mattress?
Yes, on a mattress.
That kind of suggests that the mattress was more than $1,000 though.
Yes. Yes, the mattress was very. I mean, I talked to a friend of mine, and he told me you spend a lot on your back. You're gonna need it. So yeah, I think it was a good spend. It was a very comfortable bed for sure. The unrolling the bed though was insane though. It's very hard. So recommend if you buying a bed, just have 2 people. Just have a friend.
Fair enough. Otherwise, you ruin your back while setting up the mattress. That's no good. Awesome. Hey, Lewis, this was an absolute treat for us having you on. I'm looking forward to having you on in the future again and hearing more about how OpenRouter is adopting Effect and all the crazy growth you're going through. Also, a big thank you for Mike for spoiling us with his presence throughout this episode as well. Very, very interesting conversations. I've learned a lot. So thanks a lot to the both of you.
Awesome. Thanks, Mike, for putting me in on the podcast. Right?
It was a big pleasure, and I hope to see you soon when we come to New York.
Absolutely. I'll see you then.
Alrighty.
Have fun.
Take care. Thank you for listening to the Cause and Effect podcast. If you've enjoyed this episode, please subscribe, leave a review, and share it with your friends. If you haven't done so already, you can join our Discord community. And if you have any questions, feedback, or suggestions about this episode or about Effect in general, don't hesitate to get in touch. See you in the next episode.